Alrighty, so this is chapter 7. This is my notes for series and parallel circuits. Everybody should have the formula sheet. Yes? So in a series circuit, we have the currents are the same. Remember that. That's the first thing that should pop up to you. RT is the summation of the three resistors. IT is the same. Think about a little bumper car. You're going around the same little warehouse. You should have this as part of your formula sheet. I'm just kind of reviewing because we're going to need it for chapter 7, okay? I'm going to scan this, so don't worry about it if you can't copy everything. Voltage is the addition of the 3 voltage drop across each resistor. They equal E. The source is the voltage rise. The 3 resistors are my voltage drop. That is Kirchhoff's voltage law. Resistors have the units of ohms, current is amps, E is voltage, P is power, is watts. So knowing your units are good. Knowing engineering notation is really good. The other class I went to sub for, they do not know engineering notation. They could not get their proper units. I know I expect a lot from you guys, but you guys know way more than that other class. So when I get them in AC, they're going to suffer because they have not learned what they were supposed to learn. They have also on a series circuit, we have the voltage divider rule. I don't know why I didn't have the voltage divider rule here. So, voltage divider rule is as follows. Like I said, it has to be that equation. Voltage divider rule is Vx is equal to E times Rx, over RT. Okay? So, X means that he is either 1, 2, and 3. Okay? So I'm going to scan this, guys, okay? So don't worry about him. I will scan him. And then in parallel circuits, the voltages are the same. So that means that the voltage across R1, R2, and R3 are the same. So E is equal to V, equal to V2, equal to V3. That's the first thing that you should remember. Series currents are the same, parallel voltages are the same. The resistance is the complicated formula. The long formula is what I used to tell my students. So RT is equal to R1, the reciprocal or the inverse, whatever you want to call it, the addition of the resistors that are the reciprocal of each, and then you add them, and then you take the reciprocal again. Okay? The currents are divided. Remember, you have a little van, you have 3 clones, whatever you want to say, and they go to 3 different parts. So my current comes here, and at this node, it splits into I1, I2, and I3. So he is Kirchhoff's current law. The power is the same as in the series circuit, P1 plus P2 plus P3. This guy has 2 current divider rules. We're going to do just the general one. Remember, he has parallel circuits, but there's the general one. So there's the general current divider rule, and there's the one for 2 branches only. All right? So he is IX. Remind me on this one because I don't use it as much. RT times IT over RX. I think that's pretty good. That's not the general one? I mean, just in the direct the place? Well, still the same thing, right? Okay, but it's the same thing, guys. It's alright. I'll put it the way you want to. You mean like this? It's the same thing, okay? But it's okay. It's whatever makes you guys remember it. So this is the general one. You can use it for multiple branches, for 2 branches, 3 branches, 4 branches, okay? So in parallel circuits, you have the current divider rule. In series circuits, you have the voltage divider rule. This is very important because now we're going to get to do problems. I will scan him, but I didn't want to write all of it out, okay? Just because this is your formula sheet. Okay, very good. So that's going to be page number 1. All right, can I move it? And I will, current divider rule formula sheet, this one right here, you guys should have this formula sheet. This is the same thing as that. Remember him that I gave you a copy of? But that's okay. You know, if you write it out, sometimes they say that if you write it out, it sticks in your head more. Alrighty, so we're gonna, can I move? Alrighty, so I'm gonna move to page number 2. Alright, so page number 2 is you're starting to learn different circuits. So this is gonna be page number 2, okay? And this is chapter 7. Chapter 7, we have one circuit here. Okay. I thought there were 3 different parts, but there's just one part. R1, R2, and we're not going to put numbers. We're just going to put labels R1, R2, R3, and R4. And we're going to do, as you notice, I'm not going to give you an E right now. We're just going to leave it there for you guys. Okay. So this guy is a series and parallel circuit. They have combined them together. So, okay, so many things right here. So notice that there's a resistor here that didn't used to be there before. And notice there's another resistor here that didn't used to be there before, right? So in this case, the voltage E here is not the same voltage across resistor 2. So V2 is not E. All right? So first facts. V2, if we had a V2 right here, is not equal to E. This is not a purely parallel circuit. Okay? Notice that if you kind of cover this guy, he's still not really a parallel circuit. The only way he would be a parallel circuit, a purely parallel circuit, is if you did to R3 and R4 what? You what? You combine them. R3 and R4 are in series. You can combine them, and then R3 and R4 will be in parallel with R2. So one of the reasons that I'm showing you this facts is that RT is not equal to R1 plus R2 plus R3 plus R4. It is not that guy. It is not. So don't assume that it is. All right? So when I get equations like circuits like this, the first thing I do is that I figure out what my current is doing. And we're going to use different colors so that we can see what my current is doing. My currents, remember, in a series circuits, my currents are the same in a series circuit. In a parallel circuit, they split. All right? So coming out of here, we have plus, minus, and the current coming here, we're going to call him I total, like before. So the current going across R1 is I total. He crosses through, and at this point right here, so the current through R1 is IT. You guys see that? And then at this node, the current splits. He goes down to I2, and I'm going to use a different color, and he goes through, I'm going to call it I3 just because that's the name of the resistor. He goes through resistor 3. What happens in the corner? Nothing. It just goes down. So he does not become an I4, but the current going through R4 is still I3. So that tells me, look at the current going through R3 and R4. There is the same current. Therefore, R3 and R4 are in series because they have the same current. Then they come, I3 keeps coming, I2 comes right there, and then at this node, they combine and he becomes IT. Yes? Does that make sense? So now we can start doing a little bit of combining. So they start saying that I should have put these guys over here, the facts. Over here, facts. I'll erase it. V2 is not equal to E, and RT is not equal to R1 plus R2 plus R3 plus R4, because that is a purely resistor circuit, and that is not equal to that. So I'm going to erase him. I put them on the side because I'm gonna reduce the circuit so that hopefully you guys can see what is going on. Okay, sorry about that. Alrighty, so here we are. So the first thing we're gonna do is that I want to combine R3 and R4 so that I know that these two guys have the same current. So I make it as easy as I can. So I'm gonna put everything the same, and I'm going to combine R3 plus R4, whatever that is. And R2 is here, and R1 is here. Okay? So we still have the same currents, IT, and then we have I3, and then we still have I2. Do you guys see that? Okay. What else could we do? What else can we know about this circuit? What can you tell me about R2 and R3? They are in parallel because they have different current. Okay? So, I always tell my students, pretend that you have a little guy right here. A lot of students, what they try to do is that they try to look at R1, and guess what they do? They add it to R2 because they think the current is the same through R2. So they say R1 plus R2 is in parallel with R3 and R4, the summation of that. Don't do that. Think of the little guy over here. He can only see what he can see. Right here, he could only see R3 and R4, that they had the same current. Right here, this guy can only see R3 plus R4 that is in parallel with R2. So these two guys, so right here, R3 and R4 are in series. And right here, R2 is in parallel with R3 plus R4 because they have different currents. Yes? Okay. So we're going to combine it, and we're going to reduce him even more. When you first start, you might want to start doing this, but if you feel comfortable, you don't have to do it, but you don't. So here we're going to do this. R2 is in parallel with the summation of R3 and R4, that they're in series. So what can you tell me here? He is a what circuit? It's a series circuit because he has the same current going through. So what can you tell me about my R total right there? If I have the same current going through R1 and this whole thing combination, what can you tell me about RT? You add them. So right here, we don't have variables, so we don't have numbers, so I'm just using letters or variables, but eventually they will become numbers, okay? So the first thing we always do in a circuit is that we find RT. In this case, he is R1 plus R2 in parallel with whatever the summation of R3 and R4 are. That is RT, not all of these guys with that long equation. If you do that, that is wrong. All right? Okay. Once you find RT, what is the second thing we always look at? What do we try and calculate? Okay, very good. Alrighty, there you go. Okay. So now once we find current, then we find IT. IT is E over RT. So whatever that is this current right here. That is not I2 and I3. No drinks, please. I2 and I3. Thank you. So when I say what is the current through R2, don't tell me he's IT. He is not IT. He is the current through this little resistor, or this portion right here, or that right here. If we had another resistor right here, R5, that would be the current through R5. Okay? Very good. So, we are going to start doing some problems. Okay? But I want you to see this as you go. You can find IT. Okay, if you found IT, could I go back and find what the voltage would be across him and here? Yeah. So once you have IT, you could go and find the voltage across this guy. Let's call him V parallel. V parallel is the guy right here and right here. Okay, that color you can't see very well. V parallel is the voltage across here and here. The way you find V parallel is C. V parallel is equal to IT times that whole thing right there. R2 in parallel with R3 plus R4. You will get V parallel. Once you have V parallel, could I find I2? Oh, I'm sorry. What? Okay, no problem. Is that good?
Yeah.
Okay. So once I find V, so usually what I do with these problems is that I find RT, I find IT, and I find V parallel and V1. So V1 is equal to IT times R1. It's like peeling an onion. So now we're in the center of the onion. We found IT. And now I'm going to go find other layers. So usually I find RT, IT, V parallel, and V1. So these two guys should be equal to E. Once I find V parallel and V1, then I can move to this circuit, D. And D, my step D is V I2 is equal to V parallel over R2. And I3 is equal to V parallel over R3 plus R4. Once I find I2 and I3, I verify that they're equal to IT. So check. Once I find I2 and I3, I can come up here and guess what? I can go and find the voltage across R3 and V4. Okay, so here V3 would be equal to I3 times R3, and V4 would be still I3 because it's the same current times R4. And then you would check that V2 is equal to V3 plus V4 because they're in parallel. So you start here, you reduce it, you go to this second figure, then you simplify it, you find RT, find IT, find the voltages, and then go back to this circuit and find I2 and I3, check that this is true, and then you go to E to this other circuit and you find V3 and V4 and you have everything. And then you check it as you go. You have to do this every problem we have. So let's do some numbers, okay? So this is where we're going. So get ready. Do not get behind in this chapter. This chapter, chapter 9, chapter 10, and 11 are the difficult ones, okay? Okay. How are you guys doing? Can I move? Everybody understands the sequence? Okay, we're going to do once, but first we're going to practice RT, because that is the most important thing right now that you can do. Okay, I'm going to go to number 3. Is that okay? Are you, if you're not done, I'll wait. Good, Diego? Okay. We're not doing pages. I'm doing my own problems. Number 3. So, this is example number 2. This is page 3, example number 2. There is nothing in the book. The book is extra problems for you guys to go practice. And remember also Whisk Online. You can also go practice with that. So, the only thing that we're doing here is we're finding RT. And you tell me where are there currents and where is there not currents. And we're going to call him R1. We're going to call him R2. We're going to call him R1, and we're going to call him R3. So if I had to reduce this circuit, how would I reduce it? I'm sorry? Add R2 and R3. Because R2 and R3 are in series. Yes? R2 and R3 are in series. So let's redraw it. So if you see my currents, notice there's no resistor here, but there is IT if there has been a resistor. At this node right here, we're going to split into I2, and I2 is going to continue all the way through. So the current going through R3 is I2. Yes? And then the current going down R1 is just plain I1. And then at this node they combine and he becomes IT. Yes? Okay. And like Mike said, these two guys, R2 is added to R3 because they are in series, because they have the same current. Yes? Alrighty, so let's reduce it. So I redraw it, and I have R1 of 100, and I have R2 plus R3, which is equal to 250. Sometimes the book likes to write R23 is equal to 250. They like to do that too in the book. Okay? Alrighty. What can you tell me about these two guys? They are in parallel. There is I1, there is I2, and there is my IT. It's recognizing what's in series and what's in parallel. This is going to differentiate the men from the boys and the women from the girls. This is no joke. You need to understand this, because I will know right away if you know what you're doing on this electronic circuits. So RT, if they're in parallel, so you're telling me that R1 is in parallel with R23, yes? Because why? They are in parallel because they're what? They share 2 points and they have different currents. Also the same thing, great. Because they share 2 points. I like that one. 2 points, 2 nodes, or they also have different currents. Alrighty, so that means that I can come here, redraw my circuit, and do R1 in parallel with R23. What is that? It's going to be 100. RT is going to be 100 plus 250, reciprocal of that. So where's my calculator? It's going to be 100. Oops, wrong one. 100 reciprocal, 250 reciprocal, plus it's 71.43. Is that what you guys got? I hope so. 71.43. You should try with me right here, guys, because if you're not getting that, we can go and that is not working. We can go and try it. Yes. So RT is equal to 71.43 ohms. So this guy right here, I'm trying to not have it all so crowded. Let me move this guy, make him smaller. There we go. RT is equal to 71.43 ohms. Yes? Okay. So that's all we're doing for this circuit, finding RT. So all we're doing here is find RT. So what I would recommend is make sure that you know how to find RT. It is very important, even though the quiz tomorrow is going to find everything. So number 3, we're going to do another problem. This is going to be a big problem too. We're only finding RT. You can find everything, but we're just doing that for these 2 problems. So this guy is going to be like this, current, and then this guy is going to be a little bit like that, and then he's going to be over here, and then he's going to be right here, and then this guy is going to be right here. He's going to be R1 is 100. He is R2 200. He is R3 300. And he is R4 is equal to 100. Okay? Okay. So what can you tell me of this circuit? How can we reduce it? What's in what? Which one? R1 and R4 are not in parallel. Remember my little guy right here. He can only see what he can see. My little guy can only see what he can see. I'm sorry? Who said that? Say that again. Look at my little guy. My little guy can only see R3 and R4. And then the magical thing is that we look at my current. When in doubt, get your red marker, come out here, and he's going to be IT. R1 and R4 are far from each other from the little guy. They're not in parallel. Then you're going to continue with IT. The current going through resistor 1 is IT. At that node, he's going to split into I2, and we can call him whatever we want. I just called him I2. You could call him I little lamb, whatever you want. But as long as you understand which one is what. And then right here is I3. Pretend you're in a little car. There's the corner. There's no intersection like right here. So he just turns around and he is still I3. Because the current are the same, R3 and R4 are in series, okay? Then he continues, and at this node, I2 and I3 will combine, and if there was another resistor here, he would be current through it would be IT. Therefore, the little guy is telling me that R3, you can't see that one? Yeah, you can. R3 and R4 are in series because they have the same current. So we're going to simplify him, and he's going to come over here. Is it necessary to simplify? Not really. When you become really good at it, you're going to be able to see it. And then we can just put this guy right there. So he is R3, R4, 300 plus 100 is 400 ohms. And R2 is still 200, and R1 is still 100. Always look at the little guy perspective. Never start saying R1 is something with R3 or R2. No. Look at what this little guy is doing. I still have people on the final that will say R2 and R1. R1 and R2, you add them. It's wrong. Don't ever start with R1. Yes? Huh?
I said I think the whole little guy thing helps a lot because...
Really?
Yeah.
I don't know.
It just gives a good image of like where you look at.
I like the little guy. The little guy can't see that far.
Yeah.
He can't see mountains. He can't see over R3, 4, and R2. So if that helps you, fine. I'm just saying I've used different analogies and people seem to like the little guy, but we'll see. Alrighty, so what can you tell me about this circuit? Don't start with R1. R2 is in parallel with R3, 4? Yes. Because, look at the currents. If you forget, IT is equal to I2 and my I3 right here. So these two guys right here, they'll combine and he becomes IT. Remember him, because if there's a resistor right there, you need to know that. So right here, this guy is telling me, my little guy is telling me that R2 is in parallel with R3, 4. They're in parallel. That means parallel, but I'll just write it out. Cos, they share a common node. I like that. They share a common node, that guy and right there. Share 2 points. And they have different currents, I2 and I3. They're different. So when we combine these guys, basically, what's R2 in parallel with R3? What is 200 in parallel with 400? What do you guys get? Did you do it in your head? Oh, okay. I was like, wow, that's pretty good. I didn't even see you move your fingers. Wow, that's pretty cool. All right, so this is going to be my R parallel. This guy is just called R parallel, these two guys together, okay? Alrighty, so when I redraw my circuit, look at what we get. So this is my R1 100, and this guy is my R parallel 133.33 ohms. Is the current the same in the circuit? Is the current the same? Yes. The bottom one. Yes, it's a series circuit, guys. Look at my little guy. My little guy can see both of them. That means that, and then if you go and get the current through here, he is the same current going through all of that. Think of your little bumper car. You just go around the corner. Same current. So what is RT at this point? What's RT? What's R1 and R in parallel? They are in series. Yes, series. R1 plus R parallel. R1 is 100 plus 133.33 ohms is equal to 233.33. Why are they in series? Because R1 and R parallel are in series. Because they have the same current. And I'm abbreviating a lot here, okay? You could also draw, if you wanted to, your final circuit, which is just one resistor. Some people don't like to do the redraw. Some people like to do the redraw. When you first start looking at series and parallel circuits, redrawing the circuit really helps. Once you do like 100 problems of these, then you don't have to redraw it anymore. But as you start, you should do it. I really recommend it unless you've seen electronics before. Otherwise, it gets a little difficult. Okay? Alrighty. So, are we still doing RT? Come on. We got to do some real stuff. So I have more RTs. Okay, I'm going to do this one. I think this one will be good too, to give us a little bit of practice. And then we're going to go and do an actual big problem. Okay? Okay, let me see which one is the hardest. Yeah, we're not going to do that one. Okay, so I'm going to move to number 4. Is that okay? You're still writing? Oh, wait. Are you done, Cole? Okay. So number 4. So this one's a little bit more, a little bit bigger. They like in the book, they call it block diagram. So we're going to start, if you like block diagram. I used to not like block diagram, but when I got to AC, it really is helpful. I don't know how much it helps in DC, but in AC it really helps. So here, 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 and here. So R1 is 800 ohms. All we're looking for is RT. At this point, RT is very important. And then this guy is R3 is 200. R4 is 100. R5 is 400. Yeah, 400. And R5 is 50. Think about what the little guy can see. We're going to find RT. That's all we're looking for. Don't start with R1. R1 should be your last problem right now. So what can you tell me about the circuit? Oops, I did 5. R5 and R5. This is R6. There you go. R5 and R6 are in series. Yes? And R3 and what? Nope, not series. So let's look at what my little guy first has. So let's look at the little guy. Let's start with R5 and R6 first. So let's do him first. So right here, think about current is coming out. He is IT. At this point, he's going to split into I2 and into I3. Let's call him I3. At this node right here, let me see if I have enough colors. He's going to be, see how I said 3? We're not going to do 3 because we're going to call him 3. All right? So we're going to call him, let's call him IX. We can call it whatever we want. Let's call him IX just because we have no resistor. And if I call him I3, we're going to get confused with this guy. So I3, and then we'll call him right here, I4. And when he combines here, what is he going to become? Okay, be careful before you say a number. What is he going to be? When the currents come into a node, the summation of the currents leaving the node should equal the summation of the current coming into the node. So if these two guys are coming into the node, I3 and I4, what should we call this guy? IX. I was going to call him I5, but I didn't want to confuse you guys yet. So we're going to call him IX. The current through here is the same current through here. We'll see it in a minute once we start simplifying. Then here the current, remember we can call him IX, you know, Mary had a little lamb, whatever we want to call him, as long as we know what currents are going through what resistors. Okay, so in the book they like to call something called block diagram. So they would say that this guy is one block, and they want to call that this guy right here is another block diagram. So they like to block resistors to show me that right here these two guys are in series. So right here the little guy tells me that R5 is in parallel, I'm sorry, not parallel, in series, yes, sorry, I got carried away looking at something else, is in series, are in series, because they have the same current. So you add them up, okay? So right here, R5 and R6 are going to be 450. Okay? Alrighty. So you could redraw this guy. Let's take baby steps. We can redraw him. We can do this guy. R2. And then we'll leave that block diagram right here. Okay, I'm going to replace it with one resistor. You're going to tell me what that is in a minute. Right here, he's going to be R5 plus R6 is 450 ohms. Huh?
So if you just put 1, then wouldn't it just be RX?
No. So I'm putting 1 because this little guy right here represents the result of this. What can you tell me about R3 and R4? They are in parallel, not in series, because why? Because you have two common nodes or 2 points, and I3 and I4 are different currents. So this guy right here, let's call this is a block diagram 1. So that is relating to that. This is block diagram 2. So block diagram 2 says, okay, right here. This is block diagram 1. And then block diagram 2 is right here. Is right here. And that guy tells me that those two guys are in parallel. Those two guys are in parallel. So R3 is in parallel with R4, cause different currents, I3 and I4. So what's 200 and 100 in parallel? 66.66. Yep. So right here, we're going to get 66.67 ohms. Yes? Yeah. So that number right here is going to go right here. So he's going to be R3 in parallel with R4, which is going to be equal to 66.67 ohms. R2 stays the same, and R1 stays the same. Yes? Okay. So this is block diagram 1 and 2. So I don't know if you guys like the block diagrams. Some people do, some people don't, so just bear in mind. So you could put a bigger block diagram that encompasses both of them, but it's up to you guys. So anyway, so right here is IT. We still have I2. What can you tell me about this block diagram 2 and this block diagram 1? They are in series because we have one resistor, we call him IX. Same current goes around the corner and he comes around the corner IX. So the little guy sees those two guys in series. So he sees 66.67 plus 450. They are in series because they have the same current. Okay? Very nice. And we can make it even smaller. So what is that equal to what? 66 point what? 516.67. I'm going to say 7. Yeah, that's good. That's good. Close enough. So this guy right here. So that number right there is right here, 516.67 ohms. And this guy is R2 500. And this guy is 800. So what can you tell me about this circuit right there? R2. Just the 516.67. I don't know what to call him. That's why I put the number, because R2 in parallel with that number right there. Oh yeah. Yeah, she started saying it's in parallel with I don't know what to call that.
Yeah.
That's all right. So, and he is IX. So these two guys are in parallel. So my little guy tells me that 500 or R2 is in parallel with 516.67 because we have 2 points or we have different currents, I2 and IX. Okay? So what is the result of that if they're in parallel? What do you guys get? To who? $254.1. Very good. And so the end comes, and here, this guy comes here, 254.1 ohms with 800. What can you tell me about the circuit? They're in series. So RT is equal to 800 plus 254.1 ohms, which is 1.054 kilo ohms, because they are in series. So my little guy tells me right here that 800 and 254.1 are in series because we have the same IT. There you go. Alrighty, that is just RT. Let's go find everything else. You're gonna have fun. You better get lots of paper. Oh, another thing that I'm gonna put in there. What if there had been a short right here? So let's do that problem. So let's pretend we have the same problem, but now we have a short. Okay? So number 5, example 5. So we have him, and him. And we have everything the same. And we have 400, and we have 50. And I have a short right there. What is RT? Is it the same? No. It is different. So all my current at this point at IX coming out of that parallel circuit is going to come this way, and this guy is like it's not even there. So just one problem, one little short will change everything. Okay? So let's look at what RT would be. We know that he is in parallel, right? So let's try to do it a little bit faster. I'm going to show you the fast way. You might not like it, but you have options. Okay, let's put all this stuff together and then we'll do that thing. Okay, very good. So, you could redraw it like we've been doing it, or you could look at this circuit, because some people are like, I hate redrawing it. I know this stuff. I'm like, that's okay. It's okay if you know it. So you look at it and always look at it from the little guy perspective, okay? And you can take an overlook, because we went through all the steps, and so you guys know more or less this circuit. So if you did not feel like you wanted to redraw it, that's fine. But always start with the currents and with the little guy, okay? So what I would do if I was you guys is that I start from the little guy, and I know that R3 and R4 are in parallel. So I would write R3 is in parallel with R4. Okay? You know that because we did it right here. But now without these numbers. It's not going to be 516 because now we don't have that part. But we have R3 and R4. I'm going to do it in variable form. You could also do it with numbers. Okay? And then once we get that number, what is that number in relationship with this R2? They are in, nope, parallel. So he's in parallel with R2 because there's I2 in parallel because they're different currents. So he would be, these two guys are in parallel, and then the result would be in parallel with R2. Okay? So you put that all in big brackets, or you can redraw. And then the final thing, this all combines to something. What is all that if it was drum resistor in relationship with R1? Series. So I'm showing you two different ways. Oh, R1 is 800. You could go redraw it every single time. Sometimes it helps. Sometimes it's more confusing. You have to be the judge of that. So 200 in parallel with, this is 100. I put 400. Did you guys see that? Oh, tell me. Keep me honest here. 100. So 200 in parallel with 100, you said 66.67. And in parallel with 500? 58? Wow, not that I don't trust you, but you know. I don't trust anybody when it comes to math and money. 58.83, you were right. Alrighty, 58.83 plus 800 is 858.83. So, you can be at this point where you can redraw every single one of them. Just make sure you bring a lot of paper. Or after so many of these, you will be comfortable enough that you will see this. So there's option 1 and option 2. I don't care how you do it as long as you get the right answer. Does that make sense? Okay. I would start with this, but some people get confused So let's do a big problem and you tell me what you're going to do. We're going to find everything. Everything. Okay? Let me make sure I do. Oh, yes. This is the different one. Okay. Are you guys ready? Okay, be ready because we're going to find all the voltages, all the current. None of this problem. We're going to do another one simpler. All the voltages, all the currents, all the powers. And we're going to do Kirchhoff's voltage law, Kirchhoff's current law. We're going to do only Ohm's law, but that means that you need to use current divider rule or voltage divider rule to double check your answers. Alrighty. I'm so sad I'm not going to be here. And we would just do problems. When I'm 90 years old, this is all I'm going to do. If I get dementia, it's not because I did not try it. But this is so much fun, guys. Especially when you don't get the answer, then you have to go debug it. And that's not fun. Okay, very good. So let's start with this. Oh, how are we going to do it? Are we going to do little problems or are we going to do RT? Okay, I'm going to leave that right there. Okay, very good. I got to plan how I'm going to do these circuits. Oh man, there's no resistor right there. Okay, so don't forget a resistor here if they give it to you in the future because it throws everything off. You thought it was going to be that easy. Haha! Look at that. There's a resistor in the middle. Alrighty, R1 is equal to 400. R2 is, man, there's not enough room. R2 is equal to 100. R3 is equal to 200. And R4 is equal to 200. Alrighty, very good. Voltage is 50 volts. E is equal to 50 volts. Okay, first thing we're going to do is find out who is in series based on my little guy. So what do you guys think? That's one answer. What else? 2, 3, and 4 are in parallel. All three of them. So, get your marker. Yes, he can only see R3 and R4, but this is the case where you want to make sure you take your marker. And at this node, he's going to split 3 different ways. I2, I3, and I4. If there was another resistor over here, he would be part of I4. At this point right here, I3 and I4 combined only. So the current coming into here, so watch this guys, because this is important. If there was a resistor right here, the current going through that resistor right here would be only I3 plus I4. Let me repeat myself. If there was a resistor right here, let's pretend there was an R5 right there. The current going through that R5 would be I3 plus I4. Because the currents combine here, I3 plus I4. You see that? You gotta be very careful. Then, but there's no resistor. But if there was a resistor, that's what you would use. And then at this point right here, they combine and become IT. Right there, IT is equal to I2 plus I3 plus I4. But this section right here is only I3 plus I4. Therefore, you could have, if you wanted to, you could have said, oh, they're trying to trick me there. This is really just R2, R3, and R4. Ha ha ha, right? There you go. The little guy could see that too. Alrighty. So, we're going to combine them. And so, I should have made them bigger because we're going to use it later. So, what's RT? So, R2, R3, and R4 are in parallel. So what is the, it's going to be 100 in parallel with 200 in parallel, parallel, addition, we're finding the answer. Add it, and 200. Oh, you guys should know what this is. It's 50. 200 and 200 is, no, 200 and 200 is 100.
Yeah.
You know what you were saying. And 100 and 100 is 50. So without even using a calculator, you should see that, hey, I could combine these two. When the branches are the same value, they get half. So it's 100. So you can combine these two to 100. And then 100 in parallel with 100 is 50. Or you could do it the long way. Okay? So all this guy is 50. When you have that guy, you could combine it to 50 and 400. Yes? These three things is right here, are parallel. Right here. So what do I do with these two guys? They are in series. So RT, number 1, RT is equal to R1 plus this whole thing in parallel. So 400 plus the whole thing, 400 plus 50 is 450. Wasn't that beautiful? Oh, yes. All right, number 2. What do I do after I find RT? Another what? The current. Very nice. So we're going to find IT. We're not finding I2. We're not finding I3. We're not finding I4. I am using the red marker so that when I ask you, what is I2? What is I3? What is I4? You don't tell me that it's IT. It is a different color in my picture. So IT does not equal I2. Do never tell me that R1 is in series with R2. Do not be that student. If I get that on the final, you did not learn anything. So IT is equal to E times RT. E is 50 volts. RT is 450 ohms. So what do you get? 50 divided by 450. What do you get? 111.11 milliamps. IT. Make sure you use 2 decimal points and you circle your answer. So that is IT. Okay. So, right after we come over here, look at this little figure. We're going to call them different figure numbers so that you know what we're referring to. This is figure number 1. This is figure number 2. And this is figure number 3. So let's look at figure number 3. In figure number 3, you have current going through all this guy, right? You have a voltage drop across him, V1 and V parallel. I have current going through him and I have an E. Can I find the voltage drop across him? Across this figure 3.0. Do I have current? Yes. Do I have resistors? Yes. So I can find V1. So this is IT. This is IT. So step number 3, I'm going to find V1 and V parallel. Okay? Yes? So number 3 is going to be using figure number 3. So number 3, I'm going to look at figure number 3.0. So I can find V1 by doing IT times R1. So 111.11 milliamps times 400. And then V2 is going to be, I'm sorry, not V2. V2 is right here. That is not, okay, it is going to be the same thing, but right now we don't know that. V parallel is equal to IT times R parallel. So he's going to be 111.11 milliamps times 50. So if I multiply those guys, what do I get? 1.1.11 milli times 400, what? 44.44 volts. And then if I do the next one, I get, what do you get? No. What do I get for this one? This is 50. 5.56 volts. And I check. Does V1 plus V parallel equal to E? Guess what? It does. So as you go, it's going to be very important to check your answers. So from this figure number 3, I can get V parallel. All my voltages, I can move them over here. He's going to be, V parallel is going to be the same thing as V2, V3, and V4. Do you see that? So you're going to go here. We did all these guys, and they're going to be 50, not 50 volts. What is that? 5.56. So this guy is V1, V2, and V3, V2, and V4. And they're all going to be, this guy, V parallel, which is going to be 5.56 volts because they're in parallel. And V1 is going to be right here. V1 is going to be equal to 44.44 volts. V1 is going to be 5.56. I don't know where to put it because it doesn't fit. V2 is going to be 5.56. V3 is going to be 5.56 volts. And V4 is going to be 5.56 volts. So, you started with the big circuit, we reduced it, and we reduced it even more. First thing we did was we found RT. Then we found IT. Then we found voltages across V1 and V parallel using figure 3. Then we checked it to make sure that V1 plus V parallel was equal to E, and they did. So number 4 is going to be based on this guy. Step number 4 was really to check it. We did. And number 5 is basically going to be, we're going to look at figure 2. And at figure 2, we brought the V parallel from figure 3, which is telling me that V parallel is equal to V2, V3, V4, because this portion got reduced to this 50 ohms. Yes? Oh. Is that better? More.
There you go.
Okay, good. Because we can't see that guy right there. Okay, very good. So, these guys are all 5.56 volts. And my V1 is equal to 44.44 volts. It's still equal to E, right? They're still equal to E. So we are in figure 2.0. So now we're going to go find, guess what? All the currents through all the different branches. And we're going to go back to figure 1.0. So we're going to go to number 6 over here. And we're going to be looking at figure 1.0. Figure 1.0 says that we're going to find my current I2, my current I3, my current I4. So the voltage across I2 is going to be, what is the voltage across R2? 5.56. V3 and V4, we're going to divide it by R2, R3, and R4. So we're going to have 5.56 volts divided by 100. 5.56 volts divided by 200. And 5.56 volts divided by another 200. So we're looking at all our currents. Okay, we're going to zoom in a little bit. So let's do the math for that guy. 5.56 divided by 100. He's going to be, oh, let's do it in green. 55.6 milliamps. So the current going through him is going to be 55.6 milliamps. The current through I3 is going to be 5.56 divided by 200 is going to be 27.8. And guess what? What's the current across I4? The same thing. So, let's check. Step number 7. Check KCL. Here over here we check KVL. Here we're going to check KCL. Does IT equal I2 plus I3 plus I4? If it doesn't, we did a mistake. So 55.6 plus 27.8 plus 27.8, guess what it is? 111.2 milliamps. Isn't that beautiful? It is the same. So we are in figure 1. In figure 1, everything is there. We have 5.56 volts. We have 5.56 volts. Nothing fits because I should have done it bigger. And 5.56 volts. We have different currents. The voltage across this resistor is 44.44 volts. Okay. So what do you think we need after that? Power. We're going to do PT. Can't believe we're going to stick everything in one page. We might be a little tight. So number 8. We're going to find PT. PT is E times IT. E is 50 volts times IT is 111.11 milliamps. So if I do that, 50 times 1.11.11 milli, what do you guys get? Well, that was, okay, yeah, it's over here. What do you guys get? Well, if you guys are looking at that, I'm going to look at this one. What is that? 5.56 watts. Very good. I was looking for that. All right, so look at this. So we got to be careful with P1, P2, P3, and P4. We have to find the current and voltage through each one of them. We're just going to do simple pi. All right? So simple pi is I1 times V1 or E1, whatever. I2 times V2, I3 times V3, and I4 times V4. So you have to grab the right current. So I1 is what? Oh, look at this. I1 is IT. Yes? So this guy is IT. IT is 111.11 milliamps times, what's V1? 44.44. Okay, we'll do the math in a little bit. I just want you to see, make sure you get the currents, the correct currents. I2 is 55.56 times the voltage. Where's the voltage? Right here. 5.56 is for all of the other ones. So 5.56 because they're in parallel. And then P3 was 27.8 from right here. And then this guy, 4 was 27.8 milliamps. And then you can go and solve them. And then step number 9 will be, does the addition of all these equal PT? So check that PT is equal to P1 plus P2 plus P3 plus P4. Alrighty, so let's start looking at them and see what we get. 111.11 milli times 44.44. Wow, this is a big number. 4.94 watts. So the majority, look at that. The reason the majority of the wattage, I guess, is because the voltage and the current is the highest at P1, because my resistor is the biggest there. The combination of these 3 resistors is only 50. So let's do the other ones. 5.56 times 55.6 milli. He's really small. 309, is that what you guys got? Yeah, 309.14 milliwatts. And look at this guy. He's half of that guy. So it should be half. 57. Yeah. And the other one is the same because it's the same as the other one. If you add them, do you get the answer? Let's see, 154.57 milli times 2 times plus 3.09 milli plus, and then 4.94. Voila, 5.56. Look at that. So it does check. So, what time is it? 2:30. Good time. So we're gonna stop